All right, so in this video, we're going to look at the ambiguous case. So we just learned about the law of sines, and that is a way to solve a right triangle when you're given two angles on one side. Did I say right triangle? Any triangle. All right, so if you're trying to solve a triangle when you're given two angles on one side, you use the law of sines. Now, what if you're given two sides and one angle, and it's not the angle in between those two sides? All right. That's something called the ambiguous case, and we'll talk about that more in a second. But first, let's make this picture together. Yeah, if for whatever reason you can't do this along with me, just sit back and watch. That's fine. But I highly encourage you, if you have your Chromebook and everything's working appropriately, to do this with me. All right, so I will go a little slower for that reason. And again, if I go too fast, just tell me. And if you're watching this video, just pause the video. All right, so first make a line. So you should be at geogebra.org/geometry. All right, we're gonna make not a segment, but a line. So we're gonna put a point there and a point there. So a line is gonna be like parallel to the bottom of our screen. Now, you don't have to do this unless you want to, this next step, but I'm gonna do it because for presentation purposes. All right, I'm going to hit, oops, I didn't mean to do that. So there's the undo button. If you ever make a mistake, the undo button's right there. All right, I'm gonna hit this little gear here to make the font bigger. So hit settings and hit this gear again, and we'll make the font bigger. You don't have to do that, but that's just so if you're watching at home, you don't have to squint or get really close to the screen. All right, so at this point, everyone should have a line. Now, remember, you have the line tool selected. So like if you press anything, it's gonna make lines. All right, I wanna undo that. If you wanna adjust anything on your screen, you wanna hit the arrow tool. So let's say you didn't like where you put point A, you can now move it when you select the arrow tool. All right. Okay. Now I'm going to take a segment. So I'm going to hit line segment, and I'm going to make a segment AC. So I'm going to hit point A and then another point up here. Okay. Then I'm going to make a third segment CD by clicking point C and then making another segment there. So we should have this sort of like incomplete triangle. All right. And as you catch up to me, I'm just going to hit the arrow tool and adjust these letters so it looks a little nicer. All right. Okay. So now, again, if I'm going too fast, just stop me. Now I want to find the measure of angle CAB. So the angle tool isn't available, so you have to click more. And if you click more, you'll see something measure and angle. All right, once you've selected the measure angle tool, you should hit points C, A, and B, or B, A, and C in that order. All right, and that's going to give me this measure of this angle. All right, so what we're doing is we're creating a manipulative to represent a triangle to explore the different cases for angle side, side, all right, when you're given one angle and two sides. So now let's find the length of the two sides, AC and CD. So I'm going to click segment AC after clicking the distance and length tool. All right, so click distance and length and then segment AC, and then click segment CD. All right, so your numbers don't have to be like mine, and I'd be very surprised if they were. All right, but you should have a picture that looks like this. And again, your angles and numbers should be different, probably are different. But if they're close to it, that's cool. All right. Now, this represents the angle side case because I am given an angle right here and I'm given two sides. And it's not side angle side because I'm not given the angle in between the two sides. All right. If I knew angle C, then it'd be side, angle, side, but it's angle side. Or if you go in reverse order, side, angle. All right. Now, this is called the ambiguous case because it's not clear that you can make a triangle. All right, look at it. We have this situation where this side over here isn't long enough. It doesn't make a triangle. Or you could make a triangle. Or maybe notice how the angles are 54 degrees, 10 points, and then the sides are 10.7 and 8.8. All right, you can actually make two triangles like that. All right, so you can make two triangles with a 54-degree angle and a 10.7 unit length side and an 8.8 length side. All right, so that's what it means to be ambiguous. The word ambiguous means unclear. All right, whereas when we have side, 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 or angle, side, angle, it's not ambiguous. We know exactly what the other two sides and angle or other three angles will look like. All right, but when you're given side, angle, angle, all right, it's ambiguous. And then we have to look at it on a case by case basis. All right, so first case we want to look at. All right, so before I even go any further, I want to go over some important vocab. All right, this angle here, I'm going to use my iPad for a second. I'm going to refer to as the given angle. All right, so when we have angle side, side, A is that given angle. All right, and then we have this side. All right, that I'm going to refer to as the adjacent side or side adjacent. Okay, so that side that's always next to the given angle is always going to be known as the adjacent side or the side adjacent. I don't know. I might interchange those words. All right, and then this is going to be known as the side opposite the given angle. All right, and notice how, okay, ASS, or often in textbooks written as SSA, they mean the same thing, but that's the ambiguous case. All right, and so anytime I refer to the side opposite, no matter if that's 8.8 units long or less or more, that's the side opposite. That's the side adjacent. That's the given angle. All right, so the first case we're going to look at is when the given angle is obtuse. Okay, so if I make sure the arrow tool is selected. So right now the arrow tool is selected because you don't see it there. But let's say I selected like point. Now the arrow tool appears, or also in the top of the screen, you'll see move. All right, I want the arrow tool selected. The first case we want to look at is when the given angle is obtuse. So I'm going to adjust point C so that this angle right here is obtuse. All right, mine's going to be 108. It doesn't matter what yours is, as long as it's between 90 and 180. All right, so that's the first case we're going to look at. The given angle is obtuse. Now, if I keep that given angle obtuse and I just move around point D, we could see that, okay, we can either make a triangle, all right, or we can't make a triangle. So when the given angle is obtuse, there's two possible things that could happen. There's no triangles that could be made. So if I said, hey, find the missing sides and angle of a triangle where the given angle is 108.2 degrees, the side adjacent is 9 centimeters, and the side opposite is 7.5 centimeters. You would eventually say, that's impossible. You can't make a triangle like that. But if I said it was 108.2 degrees, 9 centimeters long, and then the opposite side was 12 centimeters long, then, okay, then you can make a triangle. So then you would find angle C, by using the law of sines, you would find angle D, and then you would find side AD by doing the law of sines. Now, my question to you is, what needs to be true about this opposite side in order to make a triangle? So if you think you know that, put it in the chat. All right, what tells us, and I'm giving you a hint, it has to do with the opposite side of the given angle. What needs to be true about that in order for this to make a triangle? See, this would make a triangle. All right, this wouldn't make a triangle. All right, and I'm not going over here because the given angle is 108 degrees. And if I go on this side now, the given angle is not 108 degrees. It would be the complement of that. All right, so, all right, we can make a triangle. We can make a triangle. All right, now this side isn't long enough. It doesn't make a triangle. All right, now the side is long enough. It'll make a triangle. All right, here the side's long enough because I can swing it around, but now it's not long enough. Nice. So I see people sending me private messages. And most people are saying, yeah, the opposite side has to be longer than the adjacent side. All right, and I can illustrate that by making a circle. All right, so now, the answer is if the side opposite the given angle is greater than the side adjacent the given angle, so in this case, if this side is greater than 9, you can make a triangle. But if this side is smaller than the side opposite if the side opposite the given angle is less than the adjacent side, then you can't make a triangle. All right. And again, I started saying this and I stopped, but you can illustrate this with a circle. All right. The circle represents, like, if you were to keep CD 7.2 units long and like swing it 360 degrees around C, you can see all the places where point D would be, because that would be on the circumference of the circle. It would never reach the opposite side. So if this opposite side 7.2, you can't make a triangle. And then right when I make it more than 9, now you could see, all right, you would be able to make a triangle like that. All right. But once this is less than 9, it won't reach the opposite side. Okay. So with the ambiguous case, all right, steps for solving, and you'll have this for you later. All right. Are you given SSA? All right. If you're given SSA, decide if is the given angle obtuse or acute. We just looked at it's obtuse. All right. So when it's obtuse, all right, then is the side opposite the given angle a larger side? If yes, then you can solve it, and there's one triangle, and use the law of sines. If no, then you just say it's not possible. All right, you can't solve it. All right, now let's look at what happens when this angle is acute. All right, now if this angle was right, then you would just like do the Pythagorean theorem, right? If this was a 90-degree angle, all right, obviously if the hypotenuse is less than this leg, you can't make a triangle. But if it's a right triangle, you should be able to do the Pythagorean theorem. Now, what happens when this angle is acute? All right, and I'm going to keep this circle here. But someone sent me a message. I want to make sure I didn't miss it. Oh, all right. Okay, so now, what do we look at when this given angle is acute? So first, if you look at this circle, all right, we want to make sure that this side is long enough so that it'll reach. Now, if we use the circle, and look how, like, if I make this side like 6.8, all right, there's a chance for two possible triangles with a 64.4 degree angle, adjacent side 7.4 and opposite side 6.8. Like, there could be a point there or a point there. So both triangles ACE and triangles ACF have those angles, 64 degrees, 7.4 length side, and 6.8 length side. All right. So that could happen, and we'll see when that happens. All right. Or maybe this side is just long enough so that it hits it, and it does make a right triangle. All right. So point D could be where AD is perpendicular to CD, if that's just the right length. All right. Or this might not be long enough. All right. So when you have an acute angle, the first thing you want to look at is the side opposite. Oops, sorry, I didn't mean to move this acute. So is the side opposite the given angle, in this case 7.5, more than the side adjacent the given angle? All right, if it is, then you can tell by the circle that there's only one triangle that you can make. All right, so if you're given ASS and the opposite side of the given angle is more than the adjacent side, then there's definitely going to be one triangle. And then you would solve this triangle by doing the law of sines. All right. The only time it's going to really be ambiguous is when the side opposite the given angle is less than the side adjacent. So look what happens when I make this side less than 6.8. Right now, this circle will only cross side AB at one point, in this case, point D, where you can make a triangle. Notice how the other place where it crosses AB would be on the opposite side of that angle, so it would be a different type of triangle. But as soon as I make this less than like 6.8, So if I make this 6.7, all right, now this side CE would be 6.7, and notice how we have one little narrow triangle over there. And side CF would also be 6.7. So in other words, triangles ACE and triangles ACF both have a 71-degree angle, an adjacent side 6.8 and an opposite side 6.7. All right. So how do we determine if it's going to be two triangles? Because just because 6.7 is less than 6.8 doesn't mean we're going to get two triangles. All right. We could also have, when the opposite side becomes less than the adjacent side, it could be two triangles, it could be one triangle, or it could be no triangles. So what you have to do in the specific scenario when the opposite side is less than the adjacent side, because remember, when the angle's acute and the opposite side is more than the adjacent side, there's exactly one triangle. When this is less than the adjacent side, then what you have to do is you have to find the height. So what does that mean? You would have to do SOHCAHTOA to find this length right here. So now take a perpendicular line, hit point C, and then side AB, and it'll draw a line perpendicular to AB through point C. All right. So then you could place a point at that intersection and find that distance. So you click point C and point E, and we get that length is 6.5. Now, why is that length significant? Well, notice how when, I can't really see that, but notice how when this opposite side is more than 6.8, you only make one triangle. When it's less than 6.8, but greater than 6.5, you're going to create two triangles. And when it's equal to 6.5, there's only one triangle that could be created. And when it's less than 6.5, all right, again, this circle represents, if I were to swing this around, if this opposite side is less than the height, then you cannot make a triangle. So there would be no triangles in that case too. All right. And those are the different cases of the ambiguous case. All right. Now, if you weren't writing that down, that's okay. It's all in these notes here. I just wanted you to kind of see it. And we just went through all these. All right. So now we'll go through specific examples and I'll talk through all this. But just to do a very quick recap. All right. You're given SSA. The angle is obtuse. Right. That means there could be no triangles or one triangle. There's one triangle if the opposite side is more than the adjacent side, and there's no triangles if the opposite side is less than the adjacent side. All right. Let's say the given angle is acute. All right. If the side opposite the given angle is more than the side adjacent, there's exactly one triangle you can make there. All right. Because if you swung this around, it wouldn't hit this side AB and make the same triangle with the same 67-degree angle. All right, if the side opposite is less than the adjacent side, then that's the only time you have to find the height. Given angle is acute, side opposite is less than the side adjacent. Find the height, then compare the opposite side to the height. If the opposite side is less than the height, you can't make a triangle. If it's equal to the height, you can make one right triangle. Because remember, in geometry, you learned that a tangent line intersects like a circle at the radius, and that's going to be perpendicular. So if this circle just lies tangent to AB, meaning it's just long enough to reach at one point, then that's going to be a right angle. And then if it's more than the height, but still less than the adjacent side, that's when you have two triangles. All right, cool. So let's apply this now. And when you're doing these, just keep this little flow chart with you, and then you'll eventually get the hang of it. But at least now you have like a visual to tie it to. So now determine the number of triangles that are possible and solve. So we're given that side A angle A is 102 degrees, And the opposite side is 24 because remember, angle A is opposite side A. And then the adjacent side, the adjacent side is 20. So if I were to just go to our picture here and then make this angle 102, was it? 102. Might be hard to do exactly. So we might be better off drawing this picture. But at least we can manipulate it. All right, 102. And then it was 24 and 20. Yeah, I think we're going to run out of, yeah, that's going to be hard to do. So I'm just going to draw the picture here. I'm going to X out of GeoGebra for a moment. All right, now when you're doing this, when you're drawing these pictures by hand, I think it's always good to like draw it like we did on GeoGebra, like with the one side like parallel to the bottom of the screen. We'll make that angle A, so that's 102, right? So the given angle always goes right there. And then this would have to be 24 because that's opposite angle A. And then we could put the other side as the adjacent side. All right, so this, because the side opposite is larger than the side adjacent and the angle is acute, that means we're going to have one triangle. And it's going to look like that. All right, so just go to your flow chart. It's obtuse, so that means one or two triangles. Side opposite is longer than the side adjacent. So now we could just solve this one triangle with the law of sines. All right, so remember this would have been side B because that's, or angle B because that's side B, and that would be side C. So now to solve this triangle, I'm just going to do the law of sines. I'm going to use 102 and 24 since they're across from each other. So the sine of 102 over 24 equals, so now we got to find angle B. All right, the sine of B over 20. Okay, then cross multiply. So we'll get 20 times the sine of 102 is equal to 24 times the sine of B. I like doing these problems on the whiteboard because it requires a lot of room. So sorry that I'm kind of writing on top of myself here, but that's what the handbook dealt with. Divide by 24. And now we have the sine of B is equal to 20 times the sine of 102 over 24. So now we got to get our calculator out and we got to put this as a decimal. And then whatever number that comes out to be, all right, that's going to equal the sine of B. So to figure out what B is, we're going to do the sine inverse, switch our domain and range. And as remember what we know about sine inverse, it's going to give us angles in quadrants 1 or 4. So as long as B is positive, as long as this number is positive, right, and it should be because that's positive, and 102, that's in quadrant 2, so the sine of 102 is going to be positive. All right, this number here should be positive. So when we take the sine inverse of it, we should get an angle that's acute and positive, which would make sense for this triangle here. All right, so now I got to open up my PI Inspire, and again, everything disappears, so that's kind of annoying, and do that math there. So it was, remember we had the sine, and I'm sorry for having to write everything over again, but the sine of 102 over 24 was equal to the sine of B over 20. All right, then we cross multiplied and got 20 times the sine of 102, right, would equal 24 times the sine of B. So if we then divided both sides by 24, we would get that. Now we have to evaluate this number here. Right, and we hit Control Enter just to get it as a decimal. Right, and that's what the sine of B is equal to. So now to solve for B, we got to do the sine inverse. Oops, let me hit the control. Trig sine inverse of this. And then we get 54 degrees. All right, so now we know angle B is 54 degrees. So to find angle C, or 54.6 degrees. All right, to find angle C, we could then do use the fact that the three angles of a triangle add up to 180. So we get, to find angle C, you would do 180 minus 102 minus this angle, and then we get angle C. All right, then all we got to do is do one more side, and then you could just do the law of sines there. All right, so for this one, there's one possible triangle, and we just solved it. Okay, and again, law of ambiguous case is just like an extension of law of sines. All right, now let's try this case here. So we got, I'm going to move this over so I have room to make my pictures. Didn't matter when we were in a classroom on the whiteboard. All right, so now I'm going to draw my picture. So we got this angle is 40 degrees. All right, the side opposite is 15. All right, and this side is 9. Now I kind of drew that picture weird, but I think it's important to make it kind of to scale. So now we're given the case where the given angle is 40 degrees and the side opposite is 15. The side adjacent is 9. So if we imagine swinging this around, like this circle around, since 15 is greater than 9, all right, the side opposite is greater than the side adjacent, all right, that means that we can only make one triangle, and it would look like this, where we're given A and the side across from it. Now we could do the law of sines with angle B, which is across from side B, all right, by doing the sine of B over 9 is equal to the sine of 40 over 15. All right, so now we got to solve that on our calculator. And I want to go through these steps here because it's a little different, because before when we did the law of sines, we were solving for an angle. We were solving for sides like before today. Now we're solving for an angle. So there's an extra step of doing the sine inverse. All right, so we had the sine of 40 over 15. And again, I wish I could keep the picture up as I did this, but can't do that. Equals the sine of B over 9, right, by looking at the picture. All right, and then we're going to cross multiply. So we'll do 9 times the sine of 40 equals 15 times the sine of B. All right, then we're going to divide both sides by 15. And I should put that as a decimal. Okay, now to solve this equation here, I need to do the sine inverse of that ratio. Keep hitting control. I shouldn't. Come on. So then we do sine inverse of that ratio. That angle is 22 degrees. Okay, then this angle is 22.6 degrees. Then you could find angle C by doing 180 minus 40 minus 22.6. And then you could find side C by just doing the law of sines one more time. So throw back to what we did last class before the test. I didn't grade those tests yet. I will today and get them back to you by Monday. All right. 2 more cases and then we'll call it class. Just want to make sure we see what happens when we got 2 triangles. All right, so now we have this scenario where And I'm always going to draw this picture like this. That's like my default picture. And then I kind of adjust it based on the angles and the sides. But generally, I like to have the side that I don't know, like parallel to the bottom. It just makes more sense. And this angle here would be 30. It stays fixed. And then we could like move this around. All right. So this angle here is 30. That's angle A. So the side opposite A is 8. And the side adjacent A would be 16. So now we're given the scenario where it's an acute angle and the side opposite the given angle is less than the side adjacent. So three things could happen here. All right, this may not be long enough and it won't reach this side. So you would have no triangles. Or maybe it's just long enough where it reaches at one point and then we have a right triangle, which we would just solve like normal. All right, or it's greater than 8, or not greater than 8. It's greater than the height, but less than 16, where it would make a triangle like this or a triangle like that. And then we would have to solve both triangles, which I'm sure in the last example, that's what we're going to do. And I'll show you how to do that. So what we have to do is find the height to determine that and compare 8 to the height. So if I drop a line from this point straight down, I'm now going to solve this. Now, it is a 30, 60, 90 triangle, so if it wasn't, then I would probably have to do SOHCAHTOA to find H. But since I know the sine of 30 is 1/2, all right, so the sine of 30 is equal to 1/2, and also the ratio of the short leg to the hypotenuse in a 30, 60, 90 triangle is 1:2, then I could solve this and get that the height is 8. All right, so this is that weird case that doesn't happen too often, but it's when the side opposite the given angle is less than the side adjacent, but it's exactly equal to the height. So now we're just solving this right triangle. So this angle would have to be 60 because you subtract 90 and 30 from 180 and get 60. And then if you did the Pythagorean theorem or special right triangles, you'd get that side as 8√3. All right, so in our little chart here, angle B is across from side C, so that would be 90 degrees, which makes angle C 60 degrees. All right, and side C was 8√3. So again, that doesn't happen often, but it could happen where you have exactly one triangle in this particular case. All right, and then the last example I want to go over is when there are two triangles. What do you do? How do you solve two triangles? So let's see what happens in this last example. Oops. So my computer's really slow. But it is running several different programs, recording a video, recording a Zoom, connecting the iPad. Pretty impressive. The computer is only this slow. It's actually pretty good. All right. So determine the number of triangles, blah, blah, blah. So let's draw the picture. Okay. So we got a line here. Make that angle A. All right. So this would have to be 5. All right. And then this would have to be 6 because A is opposite angle A. Okay. And this is 50 degrees. So this angle is acute and it's less than the side opposite is less than 6. It's 5. So the side opposite is less than the side adjacent. So that means this is the place where we could have 0, 1, or 2 triangles. So we have to find this height here again, and we're going to have to do SOHCAHTOA. All right, and we're going to have to find this height. Now, if the height is greater than 5, then that means that this won't be long enough. It won't reach. All right. If the height comes out to be equal to the side opposite, then that's when you can make exactly one triangle, right? This would be no triangles. And then if the height ends up being less than 5, so the height comes out to be like 4.3, all right, since this is still less than that, all right, then that's when we can have like two triangles, all right? And one of the triangles would look like this with a side 6, an angle 50, and a side 5. And the other triangle would look like this with an angle 50, side 6, and a side 5. All right, and then we'd have to solve both of those triangles. So now we have to find the height. All right, we're going to have to do SOHCAHTOA. So I'm going to have to go on my calculator now and do the sine of 50 is equal to h over 6. All right, and then solve that. So if I was solving the sine of 50 degrees is equal to h over 6, I would cross multiply and I would get h is equal to 6 times the sine of 50. And if I did control enter, I would get that the height is 4.59. So it's less than 5, which means we have two possible triangles. All right. Now, because I'm gonna have to draw this. Oh, Rick and Morty, like that. All right, so now I'll draw it like this, so I could use. All right, so sorry, gonna need room. It's very hard to draw. Okay, so we don't know that side. All right, we know that this is 50 degrees. All right, by drawing with zoom, it allows me to like keep the calculator on my screen and type on it. All right, now we know that we can make a triangle like this, where this side is 5. All right, or we can make a different triangle where this side is 6, this side is 5, all right, and this angle is 50. Oops. Nope. All right, it's not perfect, but pretty close. All right, so now we got to solve these. So the first thing I'm going to do, all right, and this part coming up, if I kind of lost you because I've been boring, like stay with me because it's about to get a little different. Now we're going to do the law of sine. So it doesn't matter. We'll focus on the orange triangle. All right, if we're trying to solve for, all right, I should have to draw this for a second. Sorry. This was angle A. This was side A, which makes this angle B because 6 was side B, I believe. All right, and then this is side C, or angle C. So this is side C. And then in the pink triangle, like we're going to call this angle here B prime because you'll see it's similar to B. And this would be like a side C for the smaller pink triangle. All right, so if you focus on the orange triangle, and I had to label those so that you knew what I was talking about, we're going to solve for angle B by doing the sine of 50 degrees divided by the side across from it. So the sine of 50 divided by the side across from it equals the sine, control division, the sine of B divided by the side across from that. All right, so we're going to cross multiply. All right, and we get 6 times the sine of 50 equals 5 times the sine of B. So then divide both sides by 5, and we end up getting that the sine of B is equal to that. Someone sent me a message. Someone asked, why did I make a straight line to give a 90-degree angle? I sort of did. Remember, I did do that. before, I did drop a height right there, and I found out that it was 4.6. So since 5 is more than 4.6, like that told me that, all right, we could swing the side there or there, and it would reach. So because we found the height and ended up being less than the side opposite, then that told me I could make these two triangles. So we did find the height. Now I don't need it anymore. It served its purpose. All right. Okay. Now I got the sine of B equals 0.91, blah, blah, blah. So I'm going to do the sine inverse. Damn it, I keep hitting control. I should do trig sine inverse of this. And we get 66.8 degrees. Okay. Now, that tells me that in the orange triangle, so let me make this orange, all right, and I'll use text here, that this angle here is 66.8 degrees. I want them to make that, all right, it doesn't matter, that's green. All right, because I know it's acute, and the sine inverse of any positive ratio is going to give me an acute angle. So it gives me the one in orange, angle B in orange, because that should be acute. It's in the pink triangle where B is obtuse because it's hitting that pink line at a different angle. Now, notice how we have a right triangle here. All right. This is a right triangle. This side is 5. This side is 5. All right. Who cares what this side is? This is an isosceles triangle. Did I say right? I meant isosceles. This is an isosceles triangle. So since these legs are equal, all right, these base angles should be equal. So not only is that angle going to be 66.8 degrees, but so will this angle here. All right, so because that's an isosceles triangle, when you swing that leg around, that's 5 units long, all right, that allows you not only to figure out angle B, but it allows you to figure out the angle adjacent to angle B prime. So if this angle 66.8, then we could do, oops, it's a lot of programs to manage here. We could do 180 minus 66.8, and we get 113, which means that the angle in the other triangle here, so if I do, where's text, is going to be 113.2. And now we have two triangles that we have to finish solving. And I'm going to redraw them right here. So in pink, draw, all right, we got a triangle that looks like this now, which we know, all right, we were given angle A. I'll do this in text. This is a lot easier in text. We were given angle A was 50, all right? We were given this side here was 6. We were given this side here was 5. And we just figured out because angle B was 66.8 in this obtuse triangle, this angle is going to be the complement of it, 113.2. So now in the pink triangle, ABC or AB prime C, we now could finish solving this by finding angle C, and that's also C prime because it could be different from angle C in the orange triangle. We could find angle C prime by subtracting 50 and 113 from 180, right? And then doing the law of sines to find that third side, all right? So that would be easy to solve from here on out. And then my other triangle, I'm just going to redraw it here so we could see it. We could see what just applies to that orange triangle. So remember, there's two triangles here. The pink one's one of them, the orange one's the other one. All right. We were given that this was 50 degrees. All right. We were given that this side here was 6. We were given that this side here was 5. And we just found out that this angle so remember, there's two triangles. One's going to be acute always. One's going to be obtuse when you have your two triangles. And so this is the acute one. So that's 66.8 degrees. Now we could figure out what this angle is by subtracting 50 and 66.8 from 180. All right. And then doing the law of sines to find the third side. All right. So if we just quickly finish that off, I'm sure you could do that, but just so we're clear. All right, for the pink triangle, we would do 180 minus 50 minus 113.2. Oops, didn't mean to do that. 113. We get 16.8. All right, and then just do the law of sines to find side A, B prime. And then in the other triangle, do 180 minus 50 minus 66.8, and we get that other angle is 63.2. And then do law of sines to find the other. And that's it. All right, so that's what you do when you find both triangles. The key is once you find that first angle, all right, draw the two triangles out separately, and then the other angle, the same angle in the other triangle is going to be the complement to that, because you can think of this isosceles triangle here, and then the linear pairs that we have between 66.8 and 113.2. Okay, so I know there was a lot. It was kind of wordy. Yeah, so B prime is always the supplement to B. That is a great point. All right, so yeah, B prime is the supplement to B. And again, that's because in this scenario, all right, in this scenario, that's the angle that we're going to find first in angle side, because we're given this angle, we're given this side, and we're given this side. So we have to find the angle across from it. And then if that side swings around like to here, all right, then we create this isosceles triangle. So we're at the other place where it says 66.8, those are the base angles, so they have to equal each other. And then B prime's the complement. All right, so let me end this video. And I'm sure you might want to scroll through it later if I can figure out. I bet it didn't record. Oh wow, it recorded.